Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have started carboxylic acid and I have started preparation of carboxylic acid. Under that two method I have discussed means preparation of carboxylic acid from primary alcohol and aldehydes. Second, I have discussed from alkyl benzene. Now, third method I am going to discuss. That is the preparation from nitriles and amides. Preparation of carboxylic acid from nitriles and amides. Nitriles are hydrolyzed to amides and then to acid in the presence of H plus or OH minus as catalyst. Again I am telling you, nitriles are hydrolyzed to amides and then to acids in the presence of H plus or OH minus as catalyst. Mild reaction conditions are used to stop the reaction at the amide stage. Reaction I am telling you, RCN. R is alkyl group and with that CN is attached. This is actually nitriles. Then RCN, here in RCN N is there, CN. Then C and N triple bond is there. Then that bond will break. Out of 3, 2 bond will break. In the presence of acid or alkaline medium, means in the presence of H plus or OH minus. Means on hydrolysis this CN will convert to CONH2. CONH2 means RCN will become RCONH2, C and O double bond, and NH2 will attach the carbon with single bond, COONH2. Then how CN converted to COONH2, that you have to understand. This already I have discussed many times that CN converts to on hydrolysis CN converts to amides. This is actually amide. CONH2 is amide group. Now again I am telling you that see how it converted to CONH2 on hydrolysis. Then carbon and nitrogen have triple bond. Then out of three bonds, 2 bond will break. Then nitrogen is electronegative atom. Hence, if bond will break, then nitrogen will take the electron and carbon will become positive. Carbon will become positive. Then now if nitrogen has a negative charge and carbon is positive charge, then on nitrogen 2 negative charges are there and carbon 2 positive charges there. Then with this 2 negative on N, it will attract 2H plus. 2H plus will come to N and it will form NH2. Correct? Now this carbon has positive charge. Then what will happen? This positive charge, then here you can see water H2O, when it breaks, it forms H plus OH minus. Then here you have seen that H plus 2H plus will join to the nitrogen and it will form NH2. And now this carbon is positive charge. Then from this OH will join. OH is negatively charged. OH is negatively charged, that will join to the carbon. Correct? Then now like this way bond will be formed. See, but here again I am telling you that now OH has joined. But now this I told you carbon has 2 positive charge. Then that this OH has joined, then now H will go. Then H will go as H plus and then oxygen will become negative, 1 negative. Correct? That 1 negative, that will join to carbon positive. 1 more positive charge was there. Then now like that way it will make double bond. First OH will join because on carbon 2 plus charge is there, H plus. Correct? Then now OH will join, 1 OH will join. Then 1 positive charge is remaining. Then now this OH, H will go as H plus, then O will become negative, O negative. That will join with positive carbon. Then now double bond is formed. Then like that way CONH2 is formed and you will get RCONH2, that is the amide. Now on further hydrolysis, this now CONH2 that will convert to carboxylic acid, RCOOH. Already actually C double bond O, that will not disturbed. Only NH2, C and N single bond is there. That bond actually will break. And already NH2 is there. Then when C and N bond will break, then Cn will get positive charge and N will get negative. Because N is electronegative, it will take the electron. Then now what will happen now? That H2O is there. Then again H2O will break as H plus OH minus. Then that H plus will go to the N. N is negatively charged. There it will go. It will form NH3, ammonia gas. And now this carbon was positive. Then OH will join there. Then it will form RCOOH. Then one C and oxygen double bond was there. It from the beginning only means amide. Only OH NH2 gone and OH joined. Correct? Then this NH3 further, if suppose KCl is there or HCl is there, suppose acid was HCl, then that can convert to ammonium chloride. NH3 is there plus HCl. Suppose acid is there, HCl, then it can form NH4Cl. First it will form ammonia. If HCl is there, then it can form ammonium chloride. How? Then NH3 has a lone pair of electron. Then if HCl is there, then in HCl you know that Cl has taken electron of H. Then H got positive charge, correct? Then now this H has no electron. Then nitrogen, which has a lone pair of electron, can give electron to the H. H coordinate bond it will form. Then now it will form NH4Cl, NH3 plus HCl. Then this N and H coordinate bond and H and Cl, that is the ionic bond. Then this is a very good question I am telling you. Many times in examination question was asked that to tell the any molecule means example of any molecules where three types of bonds are present. Three types of bond means ionic bond, covalent bond and coordinate bond. Coordinate bond. Then NH4Cl is the best example. Then N and H bond, that is N and H bond is covalent bond. And H and Cl ionic bond. And N and HCl, that bond is coordinate bond. Correct? This is a very good example. But here I am telling you that this RCN first converted to amide, and amide on hydrolysis, and you have to heat it also, it will convert to acid, RCOOH. And this I told you R was attached to the CN in alkyl group. But suppose if it is a R means CH3, means if R is CH3, then it will come CH3CONH2. Then reaction will be agitage. In the place of R only you have to write the CH3 everywhere. Then when in the place of R CH3 is there, then it will be called ethanamide. Ethanamide. And ethanamide will convert to ethanoic acid. Finally it will convert to ethanoic acid plus NH3. Correct? Now other example you can take in the place of R. If it is a phenyl group, suppose a phenyl group is attached with, in the place of R phenyl group is there, benzene, benzyl group you can tell, benzene. C6H5 group is attached in the place of R. Then again this CONH2, it was suppose with in the place of R phenyl group is attached, then it became benzamide. Then CONH2 on hydrolysis directly it will convert to carboxylic group, COOH. Then it will known as benzoic acid. Means benzamide on hydrolysis it will convert to benzoic acid plus ammonia gas. Correct? In both reaction ammonia gas will form. Already I have discussed. Now next method of preparation of carboxylic acid is preparation of carboxylic acid is from Grignard reagent. Then Grignard reagent you know RMGX. R means alkyl group, Mg magnesium, X is halide, halogen group. Then Grignard reagent react with carbon dioxide, okay, dry ice. It will react with dry ice, you know, solid carbon dioxide is called dry ice. Question is asked. Okay. Then Grignard reagents react with carbon dioxide to form salts of carboxylic acid, which in turn give corresponding carboxylic acids after acidification with mineral acid. Means RMgX plus CO2. Then CO2 structure, C and O double bond is there. Carbon is in the middle. Both side oxygen is there, with double bond. Then now this CO2, C and oxygen double bond. Both side carbon is in the middle. Then here, what will happen, that double bond will break. Double bond will break and it will convert to single bond. Then oxygen will become negative and carbon will become positive. Okay. Then after that what will happen, that RMgX, that R and Mg bond will break. R and Mg bond will break. R, that will be, you can say, because Mg is electropositive. It means R and Mg bond, R has given electron to Mg. Here R in comparison to Mg, R is electronegative, you can tell. This alkyl group has donated the electron. That's why bond is formed. But when bond will break, then obviously R will take its electron. Then it will come R minus, means carbanion, you can tell. Carbanion. Carbon will have negative charge. Okay. R, you can tell in a general way, R will be negative. R means alkyl, that carbon will be negative. Then Mg will be positive. Then now CO2, I told you, one double bond converted to single bond. Oxygen is negative, carbon is positive. Then now what will happen, easily you can understand. Then R is now negative, that will come to the positive carbon of CO2. R minus will join to C plus. Correct? Then now R just joined with carbon, positive carbon, and O has joined with magnesium. O is negative, that will join with positive magnesium. And now see what you got. Already one double bond is there, C double bond O, one bond is there, double bond. Okay, that will be with CO2, two oxygen was there, then only one bond broken, C and O, double bond converted to single bond, only one bond broken, other is as it is CO, then that CO will be remaining, double bond, C and O. Then that carbon became positive, oxygen became negative. Then with positive carbon, R negative has joined, and negative oxygen, that is joined with Mg, which is positively charged. Hence now in this way you got RC double bond O, and single bond, now C and O, that bond is single, and that oxygen joined with MgX. Correct? And this is the intermediate. It is this RC double bond O and OMgX. This is the intermediate, and it is weak. This molecule is weak. Quickly on hydrolysis, that this C and O bond, C and this single bond OMgX, that C and O bond will break. Then obviously oxygen will take negative electron. Oxygen will take electron and it will become negative. Correct? And carbon will become positive. Then now hydrolysis you are doing. Then carbon is becoming positive. Then OH will attach there. H2O, H plus OH minus. That OH minus will join to carbon, which is positively charged. OH minus will join there. Correct? Then now you got RC OOOH. Main product you got. And O negative. Here what will come? Then H plus from water. That will join. Then it will form MgOHX. In the place of O minus, H will join. Then Mg, one bond is with, now two bonds are there, one with X, other with, now it will become OH. Because O negative joined with H, OH bond formed. And that O is joined with Mg. Means now OH is joined with Mg. Means OH MgX. Correct? That you will get, that will be side product. Okay, then here also you have seen that you got the carboxylic acid. As we know, the Grignard reagent and nitriles can be prepared from alkyl halide. Already we have discussed, I have discussed, okay, that how we will get this Grignard reagent? Then from alkyl halide. Okay, we get Grignard reagents and nitriles. Both we can get from alkyl halide. Okay. Then this method that is now I told you from nitrile and anide and from Grignard reagent are useful. Both methods are useful. Okay, these two methods, from nitrile you got carboxylic acid, from nitrile and amide, and from Grignard reagent. Then both methods are useful for converting alkyl halide into corresponding carboxylic acids having one carbon atom more than present in the alkyl halide. Correct? Means ascending the series. I told you this method, both methods are useful for converting alkyl halide into corresponding carboxylic acids having one carbon atom more than the present in alkyl halide. Okay. Now next preparation I am telling you, preparation from acetyl halide. Preparation from acetyl halide. Preparation from acyl halide. Acyl halide and anhydride. Okay. Then acyl halide is called acid chloride. Also you can tell acyl chloride, also you can tell acid chloride. Okay. Then how will you get carboxylic acid? Means COOH group you will get from acyl halide, means acid chloride and anhydrides. How will you get? Now I am telling you. Acid chloride, when hydrolyzed with water, give carboxylic acid, or more readily hydrolyzed with aqueous base to give carboxylate ions, which on acidification provide corresponding carboxylic acids. Correct? And from anhydride, how will you get? Then anhydrides on the other hand are hydrolyzed to corresponding acid with water, acid or acids with water. Then reaction I am telling you. First I will tell reaction of acid chloride, RCOCl. Then here CO is C and oxygen double bond is there, and Cl is attached to carbon. Then on hydrolysis there is two possibilities. Okay, that on hydrolysis directly actually Cl is there in RCOCl, then CO C and oxygen double bond will not disturb. Only C and Cl bond will break. Then Cl will take a bond will break and Cl will take negative charge. Carbon will become positive charge. Then now same way H2O will provide H plus OH minus. Then H plus will join with Cl minus. It will form HCl. And OH minus will join with carbon. Then easily you got RC double OH. Already CO double bond was there. Now OH introduced. And other product was HCl. This is the one possibility. Second, in presence of base means NOH. Base means NOH, KOH, OH must be there, OH minus. Then here what will happen? Same way that RCOCl is there, then suppose it is a NOH, then Na plus will join to the Cl minus and it will form NaCl, correct? Then now because Cl gone, then carbon is positive charge, then OH is negative, that will join with carbon, hence you will get RCOOH, or in the form of you can tell that if Na will go, then carboxylate ion you will get. Suppose Na that will be hydrolyzed, RCOO minus will be there plus Na plus or H plus, anything, RCOO minus, that is carboxylate. Okay, carboxylate ion. Then now in the same way other I am telling you that these things from anhydride, example of anhydride now I am giving you as a benzene anhydride. Then anhydride, you know, oxygen will be in the middle, one side just like acetic anhydride CH3, CO will attach, and other side also CH3, CO will attach, correct? O will be in the middle. Then one side CH3 CO will join with oxygen, other side CH3CO will CH3CO, that C that will be actually positive charge, that will join with the oxygen, both sides same way, that is acetic anhydride. Then just simply now understand, in the place of methyl group, phenyl group is attached, benzene ring, phenyl group is attached both sides. In the place of CH3CO, just in the place of CH3 alkyl group, you can tell phenyl group is attached. Then it is called benzoic anhydride. It is called benzoic anhydride. Then now here on hydrolysis, then again easily you understand that already I told you that this anhydride will break. Means in the middle oxygen is there, then it will break in two parts. Then middle oxygen will come with any one. Then continuously two oxygen you will get. If you are taking acetic anhydride, the simple example I am telling you, then CH3CO already was there. One O will also attach. CH3 COO 1 minus. Correct? Then other side you will get only CH3CO. That C will be positive charge because oxygen is taken negative. Oxygen has taken electron, that become negative. Then this anhydride is becoming in two parts. Correct? One with one, that middle oxygen will go with any one. Then other will be only CH3CO, but that C will become positive charge. Then here in the place of CH3, phenyl group is attached. Very simple way. Then main reaction is with that oxygen is negative charge, CH3, COO, 1 minus. That is a one part. Other is CH3CO. That is a positive part. Then now easily you can understand that hydrolysis you are doing, then H plus will go to the negative and OH minus will go to the positive. Then what you will get? That carbon is positive charge, then OH will come there. Correct? Then now you will get one product, you will get C6H5 COO OH. Correct? Then now you got the acid, C6 benzoic acid you got, C65 COO and OH has joined. Then it became acid. Okay. That is the benzoic acid. Benzoic acid. And other side what you will get? Only these things. I have told about these things. Benzoic anhydride. Then here I told you how you are getting these things, benzoic acid. But you will get two molecule because that this thing C6H5 COO with that OH has joined. C plus was there, OH has joined. It became C6H5 COOH. Other will be also one more molecule you will get of benzoic acid. Then how? Then now this C6H5 COO was there. O was having negative charge. One carbon is carbon oxygen double bond. Other was single bond but having one negative charge, oxygen negative charge. Then H plus from the water, OH you have used. Then H plus that will join with this O. Then again you got benzoic acid, C6H5 COO OH. Here you will get two benzoic acid from one benzoic anhydride. Now another example I am telling you, that is the benzoic ethanoic anhydride. Benzoic ethanoic anhydride means here again it is anhydride. Again it is a anhydride only. Then difference is only that one side C6H5 COO is attached. Other side CH3CO is attached. Separate, not the same. One side C6H5CO is attached. Other side CH3CO is attached. Means one side alkyl group, other side phenyl group. Oxygen in the middle. Then all things will be the same. Again you will get two carboxylic acid, but one will be acetic acid, other will be benzoic acid. I think now you have understood. Because that time you got two benzoic acid. But here again you are getting two acid, but one you are getting benzoic acid, other you are getting acetic acid. Okay, that is also called ethanoic acid. Now next preparation I am telling you from ester. From ester. Then ester formula you are knowing, RCOO R. R, both R may be same or different. But here now just to understand different R means one side suppose it are phenyl group, other R is CH3. You understand like that. Okay, then it will be called ethyl benzoate. Correct? Ethyl benzoate. One side benzene is there. Correct? Other side ethyl group is attached. Actually, now you know this is ester. I am talking about the ester, RCOO. Then one side R is phenyl group, other side R is ethyl group. You can consider methyl also, ethyl also, and no problem. But whatever be, both sides are different. Suppose it is ethyl group, other side phenyl group. Then you will get C6H5 C double O, and after that C2H5. Okay. Then now this this will give this on hydrolysis. This will give you benzoic acid plus ethyl alcohol. Easily, very easy method, because C double O, that C double bond O, that is, one is a double bond, other is a single bond. Correct? Then C double O with O, C2H5 is attached, that bond will break. O bond between O and C2H5, single bond, that will break. Then you will get 2 ion, you will get, that you will C double O negative, that you will get, and C2H5 plus you will get. Then now you got one negative charge, other you got positive charge. Correct? C2H5 is positively charged, and C double O means phenyl is attached. C6H5 C double O, that is the negatively charged. Then very easy way you can understand. H2O, H plus plus OH minus. H, then they will go to the oppositely charged. H plus will go to the oxygen and it will form benzoic acid. C2H5, it is positive charge, then OH will go there. It will attach there, then it will form C2H5OH. Correct? Then in easy way you got benzoic acid. Same way you can understand other example I am telling you, ethyl benzoate. Ethyl, this butanoate you can consider. Ethyl butanoate. From the butane, it became butanate, Butanoate. Then now here ethyl butanoate, then here only group difference is there, all things will be the same. Here in the place of phenyl group, or you can say that propyl group is attached. In the place of phenyl group, now propyl group is attached. And other side already ethyl group was there, ethyl group is there. Then again all things will be the same. You know that this compound will break into 2 ions, C double O negative, C2H5 positive. Then now suppose reaction is taking place in the presence of NOH. Na is plus, OH is minus. Then that C double O, that was the minus, with that Na will go. Na will attach. Then you will get C double O Na. Propyl group is attached, and then C double O Na you got. And other will be C2H5OH, because C2H5 is positive charge, OH will join there. Then this what you got, this thing, sodium butanoate, you got sodium butanoate, that on further hydrolysis in the place of Na, H will go, H plus. Then you will get butanoic acid. Phenyl propyl group was there, and CO is there, C double OH is there. Then total 4 carbon. That's why butanoic acid. Then I told you that preparation of carboxylic acid. Now actually some this important reaction I want to discuss, that you can tell, that is the this thing, conversion. How will you get from one compound to the other compound? Question is asked. Particularly it is asked in advanced engineering. This question is asked. Okay. Sometimes in 12th exam also here this question is asked. Actually question can be asked in any examination, but it is somewhat little difficult, not more, because you have to remember 2 step minimum. 2 step, 3 step. That's why it is asked. Difficult question is asked in advanced. Okay. advanced just engineering. Then here I will tell you conversion. How will get how will convert one compound to the other compound. Then here first I am telling you, I will actually first conversion I will tell you what you have to convert, then I will explain you. First is that butane 1-all. You have to convert butane 1-all to butanoic acid. This is the first question. Correct? Then one by one I will tell you. After that second 5-6 questions are there, I will explain all. Then first I am telling you butane conversion of butane 1-all to butanoic acid. Means alcohol you have to convert to acid. Very simple. Alcohol you have to convert to acid. Then many times I have discussed this reaction. Recently also I have discussed that you have to just do oxidation. Means on oxidation in presence of Jones reagent, Jones, Jones reagent. This question is also asked. What is the Jones reagent? Then you know this reagent, that is the chromium oxide. Chromium oxide in presence of H2SO4. Chromium oxide in presence of H2SO4 is called Jones reagent. Question is asked. Then means it is because it is oxidizing agent, chromium oxide. Then here butane 1-all is there. Total 4 carbons are there. Correct? And OH group is attached, straight chain. Then it is very easy that only in one step that OH will convert to COOH. How? That already I have told you that now because CH2OH is there, then H2 in the presence of chromium oxide, means oxidizing agent, that will go as H2O, and there in the place of 2H, one oxygen will join. Then you will get butanoic acid. Okay. Then one conversion I told you from butane 1-all to butanoic acid. Now second question I am telling you, conversion of benzyl alcohol to phenyl ethanoic acid. Phenyl ethanoic acid. From benzyl alcohol to phenyl ethanoic acid. Then now actually it is a 2 step you have to go. You will not get in one step. This product you will get in 2 steps, because benzyl alcohol you are getting that from benzyl alcohol you want phenyl ethanoic acid. Means OH you have to convert to OH. From OH you have to convert to COOH. Then already I told you one more method is that. But here it is a benzyl alcohol, C6H5CH2OH. Then how will you get? Then first this OH you have to convert to bromide. OH you have to convert to bromide. Then how you will get? Then in the presence of HBr, if it will react benzyl alcohol, not benzyl, CH2OH. Then when benzyl alcohol reacts with HBr, then OH, H plus Br minus, it will break like that, and OH minus is there. Then OH minus H plus, it will form water. And because OH minus is going outside, then C will become positive and Br is already negative. then Br will join. Then you will get benzyl bromide. You will get benzyl bromide. Then now from this bromide, benzyl bromide, that you can convert easily. Br can be substituted easily with Cn. When you will react with KCl, second reaction, then Br will go with K plus, KBr, and in the place of Br, Cn will come. Br is also negative, Cn is also negative. Hence, you will get cyanide, benzyl cyanide. Okay. Actually, here benzyl alcohol phenyl group is there. That's why you can't use zone reagent. There it was, that was the alkyl, but here it is a phenyl group. C65 is attached. C65CH2OH. That's why you converted to bromide. Bromide converted to cyanide. And now this cyanide, after that, always you remember that cyanide can easily converted to carboxylic acid on hydrolysis. Always remember, cyanide to acid. Okay, it is common. Then on hydrolysis, but you have to heat it. Then Cn will convert to COOH. Then method already same, I told you. N will go as a NH3. N will go as a NH3. And with C, 2 oxygen will join. Okay, because Cn, I just now only told you in the beginning, C and N triple bond is there. Correct? Then that 2 oxygen can join, and N will go as NH3. Okay, then like that way, now from the Cn, you got COOH, means phenyl ethanoic acid. C6H5CH2 was there, and now Cn became COOH. Then C6H5, that is the phenyl, and after that 2 carbon is there, CH2COOH. Then with this CH2COOH, C6H5 is attached, just like acetic acid. From the acetic acid, how it will join benzene? Same way. One H gone, and in its place C6H5 came. Then it is called phenyl ethanoic acid. Okay. Now this next reaction I am telling you, conversion of 3-nitrobromobenzene to 3-nitrobenzoic acid. Then don't go in the length of molecules. Means here now 3-nitrobenzene is there. Means bromine. NO2 will be as it is because you want 3-nitrobenzoic acid. Then this Br should convert to COOH. Then now here first this bromine is attached, 3-nitrobenzene. Then you have to react with magnesium in presence of ether. Then it will form MgBr. Mg has 2 positive charge, Mg is electropositive, and that carbon and bromine bond will break. Then Br will take negative, Br will take electron, and it will come negative, carbon will come positive. Then now magnesium will join with carbon, because this Mg, Br is negative, then that will also join with magnesium, MgBr, and Mg will also join with phenyl group. Okay, phenyl group can give the electron. Br went as a negative. Okay, then that Br minus joined with Mg. Mg is here metallic form, remember. Okay, it wants electron. Then Mg will come in the middle of phenyl and bromine. Means it will join with Br also, bond broken, and Br will join with Mg, and Mg will join with carbon phenyl group. There that can donate, can give the electron, because double bond is there in benzene ring. Then it will form MgBr. Then now this MgBr, that in presence of dry ice CO2, that will already discuss the mechanism, that will convert to OMgBr. See, MgBr is there, then reaction with CO2 already only today in the beginning I discussed reaction with CO2, it will convert to COO-OMgBr. CO2, just this C and Mg bond will break, correct? CO2 that will join with carbon with C double bond O, and C and O single bond, and then MgBr. How? Already in the beginning I told you. Okay, CO2 with reaction with CO2, then C double bond O, one oxygen is double bond, other is single bond, and with that oxygen which is negatively charged, that magnesium is positive charge, MgBr will attach, and it is unstable. That's why on hydrolysis it will convert quickly to means OMgBr. It will go OMgBr. O is negative, carbon is positive, then H2O, OH will join there, then with carbon positive, then you got now 3-nitrobenzoic acid, correct, and H plus will go with O minus of OMgBr, and it will come OHMgBr. Okay, then I have discussed this reaction, and okay, 2 more is there. I want to discuss 3 I told you. 4th one I will tell you now. That is a conversion of 4-methyl acetophenone to this benzene 1,4-dicarboxylic acid. 1,4-dicarboxylic acid means 2 COOH group you have to introduce. That 4-methyl acetophenone means what? That in benzene CH3 is attached. One CH3 group is attached with benzene, and other COCH3 is attached. COCH3. Then now this group, both group you have to convert it in carboxylic group. Then you have to do actually oxidation you have to do. Then here what will happen? 2 CH3 group is there. One this COCH3, their CH3 is there, and one CH3 is also attached. Hence, if you do oxidation in presence of KMNO4 in basic medium, means KOH, then quickly that CH3, both CH3, that will convert to COOK. Okay, C double, already in the COCH3 C double bond O is there. That CH3 that will just CH3 is there. Then you know that H3, that H will go as 2H will go as water. 1 H will be there. 1 H will be there. Okay. Then here also methyl group is there. Then there also that 2H will go and 1 oxygen will come. Then it became CO. Correct? 1 H is there. Then 1 more oxygen will join there. And H is there. That's why it will form COOH. COOH. Because you are using KOH, that's why you are not directly taking HOH. You are taking base, because only in base that bond will become loose. Okay. Then in the place of H, K will come. K will come. Both side, both with both CH3. Now it that CO will be as it is. Then in CH3, COCH3, that CH3 also that 2 that will go H3, 2H will go as H2O, 1H is remaining, and C will convert to CO2. Okay, then you will get now COOK. Both group we got COOK. Okay, COCH3 also converted to the COOK. 2 oxygen in both carbon joined, and CH3 went as that H2O and CO2. Okay, COCH3, that CH3 that converted to CO2 plus H2O. Okay, and there OH has joined because one nitrogen was remaining. Then now COOK you got. Then after that what you have to do? Only acid hydrolysis. Then in the place of K, H will go. Always hydrolysis means that K is there, then it is positively charged, that can replace with H. And so you will get can say COOK was there, now you will get COOH. Both K will just exchange with H. Then you will get 2 COOH group in the same ring, benzene ring, that is called benzene 1,4-dicarboxylic acid. Also it is called terephthalic acid. Now one more reaction is there, that is the cyclohexene conversion of cyclohexene to hexane 1,6-dioic acid, means also you can tell adipic acid means this ring has to break. Cyclohexene, one double bond is there in the ring, correct? Cyclohexene, each carbon 2 hydrogen is there. Only double bond, where double bond is there 1 hydrogen is there. Every carbon means 4 carbon, CH2 is there. Then cyclohexane, from cyclohexane you have to get adipic acid. How? Means 2 COOH group you have to attach, means this double bond have to break, and when this double bond will break, only then carboxylic group will attach to carboxylic group. Okay, then you will get 2 and you will get, okay, double bond will break, then both carbon will get COOH. Then how? I am telling you now. This will happen in presence of KMnO4. Oxidizing agent is KMnO4 in presence of H2SO4, and you have to heat it also. With this reaction will take place, double bond will break. For that purpose, more drastic condition you are using. A strong oxidizing agent, KMnO4, H2SO4, and again further heat you are doing. Then double bond is there. Here you understand. First one bond will break. Just first clearly you understand. Then quickly this reaction, only in one step you will get. Double bond you have to break. Only one double bond is there in ring. Then double bond will break. Then first one bond will break. Then any one carbon will get electron. Okay, any one carbon will become negative, other carbon will be positive. Only one bond has broken. First to understand. Then which is now negative charge, from that oxidizing agent will give the oxygen. Then one oxygen will join there, because negative charge means it has 2 electrons. Whenever bond breaks, then when oxygen is there, that generally when bond will break, they know that sharing of electron will be there. Then 2 electron will be involved. Then any one carbon will take both electron. Then that what will happen? Oxygen will come, one oxygen atom, that will take this 2 electron. Then now you see COO bond is formed, and other carbon is positively charged. Okay, now leave it like that, positively. Now when second bond will break, then what will happen? Now carbon which is positively charged, that will take the electron. that will take the electron. Means 2 electron will come to this carbon. Okay. Then again one oxygen will come, second oxygen will come, and it will join here with this carbon. Then both carbon now got one oxygen, C double bond. And now also you have seen that both carbon is now positive charge also, both carbon. Correct? Both carbon have now positive charge. When bond broken, one time first oxygen take an electron, and then second oxygen became positive. Now when second bond broken, then second carbon got negative and first got positive charge. Then both carbon is positive. Then now what will happen, that you can understand, because this is reaction you are doing in presence of oxidizing agent and H2SO4. Correct? Then here what will happen now, that here also you remember that double bond was there, then with that carbon, both carbon was having one hydrogen. Correct? Both carbon was having one hydrogen. Then when bond broken, then that hydrogen will be there. Both carbon will have one hydrogen. Then now just only exchange will be there. Okay, rearrangement will be there. Then now what will happen, that because both carbon has positive charge, both carbon has positive charge, then now oxygen, oxidizing agent again second molecule will give. Second oxygen will come to the first carbon. Then there H was there, that bond will break. That bond will break and oxygen will attach there. Then one bond it will make with carbon, and other oxygen, because only one bond it has formed. Oxygen is electronegative. H will come to the O. Then now it forms COH. C and O single bond, again O and H single bond. Correct? Then now you got C double O OH. Same reasoning with second carbon. Hydrogen is there on second carbon, O will come from the oxidizing agent, then it will make bond with the C, correct? And because oxygen has lone pair of electron, don't forget. Okay, sometimes it gives the electron also, because carbon is positive. Then oxygen will give the electron. Then oxygen, oxygen will make bond with carbon by giving its own electron. Then now H plus will come to this oxygen also. And one more thing, when bond will break, H plus, when carbon hydrogen bond will break, then that will come H plus. Then that oxygen, that electron will be taken by carbon only. Both carbon will take electron when H bond will break. Correct? And that also you can understand. Then O will go and take that electron, and H will come to, then it will make double bond. Then again that double bond will break. Then oxygen will become negative. Then H will join there. Then it will happen. Then like that way you will get 2 COOH group introduced in the this cyclohexane, but double bond now it became double bond broken, ring broken. You will get a straight chain. One end COOH, other end COOH, in the middle 4CH2. This is called adipic acid, means hexane 1,6-dioic acid. Last is that conversion of butanol to butanoic acid. Conversion of butanol, aldehyde, to acid. Then it is very easy. Aldehyde you have to convert to acid group. Then what you have to do? Tolerance reagent is oxidizing agent, mild oxidizing agent. Then tolerant reagent is also called ammoniacal silver nitrate. Directly one oxygen will be introduce CHO is there, one oxygen will introduce, you will get COOH. Already butanol was there, then now CHO, only one oxygen introduced. Okay, then it converts COO double bond and OH group will be there. Okay, one C double bond O, other is the OH group. Then one oxygen introduced due to oxidizing agent, tolerance reagent. Then you got butanoic acid. Okay, I am stopping only here. Next class I will start properties, physical properties and chemical properties. I will discuss next class. Thank you.